All right, this video is a word problem about creating a environment in a tube that people who are 6 foot tall can walk through. So we have a tunnel connecting two portions of the space station and has a circular cross section of radius 15 feet. So this distance here is 15 feet. Two walkway decks are constructed in the tunnel. Deck A is along the horizontal diameter, and parallel deck B is 2 feet below, so that distance of the black fat line there is 2 feet. 2 feet below deck A. Because the space station is a weightless environment, you can walk vertically upright along deck A or deck B, kind of like you can see these guys here. You have been assigned to paint safety stripes on each deck level so that the 6 foot person can safely walk upright along either deck. Determine the width of the safe walk zone. So they kind of show you here, you know, that the height of this rectangle is 6 feet. That's the safe zone. So, you know, even if they're walking here along the line you're going to paint, their head will just barely touch it, or, well, it will touch it, but it, you know, at least they don't have to bend over until they go past the safe zone over here. So you're trying to find where these X values here are of this safe zone and are of this safe zone. So I'm telling you, they're not going to be the same because that 2 foot thing right there, but it is going to be just intersections of lines. So for instance, this line right here, that's going to mark the top of that rectangular region, is going to be the line y equals 6, because the bottom, the floor of that is right on the diameter. Now this one here is going to be different. This height here is 6 feet. This length here is 2 feet. So if you think about it, this guy, the equation of this line right here has to be y equal 8. No, not 8 feet, minus 8 feet, because it's below the horizontal axis. So if you can find the equation of this circle, then you find the intersection between the circle and this horizontal line, and that'll be, you'll tape or paint the lines this distance x value from the origin and this distance x value from the origin. And since the circle is symmetric, it'll be the same distance. And then you do the same thing again for y equal minus 8 feet. And the big deal, though, is trying to find the equation of that circle. Because if you can't find that, then you're going to have a hard time actually finding the intersection. But we do know the center of the circle is at the origin. That's nice. And then what was the radius? Was 15 feet, it said. So radius is 15 feet. So the equation of that circle is x squared plus y squared equals 15 squared. And let me turn on my calculator here. And so 15 squared is 225. So the equation of the circle, x squared plus y squared equals 225. All we have to do then down here is find the intersection between x squared plus y squared equals 225 and y equals 6. And then the intersection between x squared plus y squared equals 225 and y equal negative 8. All right, now I'm going to scroll this down a little bit so that we can use the space. Okay, the intersection between these two graphs, I'm going to substitute the number 6, y equals 6, in for y. So that gives me x squared plus 6 squared equals 225. X squared equals 225 minus 36. So let's see what that is. Minus 36 gives me 189. So x squared equals 189. That gives me x is equal to, I don't know, 189 is a perfect square, but let's see, square root 189. It gives me 13.74. I'm just going to estimate it for right now, 13.7477. Plus or minus 13.7477. And everything is in terms of feet. So we're going to say this is feet. So From the center, I'm going to be on the upper deck A, I'm going to be painting the line 13.7477 in this direction, and then 13.7477 feet in this direction. Now this one here, x squared plus y squared equals 225. I'm going to stick this y equal -8 in for y here. So x squared plus -8 squared. Don't forget the negative has to be considered in the square. Otherwise, you're going to get negative numbers that you don't want. And it's not actually mathematically correct. So x squared plus 64 equals 225. X squared is equal to 225 minus 64, 161. And in this case, x is going to equal plus or minus the square root of 161, 12.6886. Remember, the minute that you put that square root symbol on your paper to solve a problem, the plus or minus has to go in front of it. That's where that's coming from in both cases. So how you have to actually answer the question. So you would say over here, deck A, paint the, what is it, safety, what do they call it? Safety stripes. .7447 feet from the center each direction. You can't see that. Let me move this a little bit. And then in deck B, paint the safety stripes. .6886 feet from the center each direction. Now, we've got to see if this makes sense. The diameter itself, so going all the way to the wall, is 15 feet. And this is less than 15 feet in both cases, so that makes sense. Now, does it make sense that deck B should be shorter distance than deck A? Well, yes. And the reason is because this is a 2-foot beam or distance in between here that takes up the space here that deck A has and deck B does not. So compensating for that in our problem right here with y equal -8 instead of -6 compensates for that, and therefore it will make a narrower space for somebody to walk in who's 6 foot tall. So in conclusion, our problems and numbers make sense, and we have a clear direction of how to paint the safety lines.